Hello everyone, welcome to topic 1.8, valence electrons and ionic compounds. This is going to be a fairly short set of notes, so yay! So the essential knowledge for this will be looking at the likelihood that two elements will form chemical bonds and how it is determined by the interactions between valence electrons in the nuclei of the elements. That elements in the same column of the periodic table tend to form analogous compounds, and that typical charges of atoms in ionic compounds are governed by their location on the periodic table and the number of valence electrons. So this should be review. We're just going to cover it so that we are all on the same page. So looking at our notes, an ionic bond always involves the transfer of electrons from the least electronegative species to the most electronegative. Traditionally, ionic compounds are described as being between a metal and a nonmetal. Based on electron configuration, elements will either lose or gain electrons in order to have a complete outer valence shell. This loss or gain of electrons leads to the formation of positive or negative ions. Ionic compounds are held together by an electrostatic force. Remember that electrostatic force are attractions between opposite charges. So like how the proton and electron are attracted to each other by electrostatic forces, cations and anions, because of opposite charges, are attracted to each other. That's Coulomb's law. We're just talking about bigger particles. In order to maintain neutrality, yeah, that's it, right? The number of electrons lost must equal the number of electrons gained. Because the number of electrons lost or gained is based on electron configurations, elements in the same group will form the same type of analogous compound. For example, all group 1 metals, lithium through cesium, will have the following format when combined with any group 7 halogen, fluorine through astatine, LiF, LiCl, any group 2 metal, and so on will form very similar ones. Again, these analogous structures are because of the need to maintain neutrality. I think I called it the rule of zero charge, that formula unit had to have no charge when you traded them, so that the total charges from the cations and the anions added to zero. So you were representing that full transfer appropriately. Nonmetals only want to gain enough electrons to fill their outer octet. Metals only want to give away enough to have a pseudo-noble gas electron configuration. So their outermost is full, either because they lost to become like a noble gas or they gained to become like a noble gas. So let's look at our IDO. Calcium reacts with a certain element to form a compound with the general formula CaX2. What would be the most likely formula for the compound formed when between sodium and element X? So if we look at calcium and element X, we see that calcium has a 1 subscript. If we trade these back, we know the value of these two. We know that calcium is 2 and the X anion has to be 1. Because calcium is a cation, it is 2+, so this must be a 1-. So now when we relate this to sodium, we know that sodium is in group 1A and forms the 1+ charge. When paired with the X group, that's 1-, so that the ratio must be NaX, which is our answer for D. Okay, let's look at the we do. Element 117, which is tennessine, was recently discovered. Assuming that periodic trends are followed, write the noble gas electron configuration and predict the formula when it forms an ionic compound with magnesium. So the nearest noble gas is radon, and I'll help you with this one. Okay, so the noble gas electron configuration, starting with radon, we go to 7s2, 5f14, 6d10, and then 1, 2, 3, 4, 5, 7p5. We know that it then since it's in group 7, it wants to go from TS to TS1 minus, just like the rest in its group. So we know it needs to add an electron. We know that magnesium, when it forms its preferred ion for energy's purpose, likes the 2+. So when we write that compound, and I like to use the trade to cancel rule, I take the non-zero digit, or not the signs, but the integers, and I trade them, and so I get MgTS2. So I have 1 positive 2 and 2 negative 1s, and those add to 0. Okay, so remember to use the rule of zero charge or trade to cancel to finish this one. Okay, the you-dos continue on. Using what we've learned prior, and the I do and the we do. Complete these. You can check your answers in class. Thank you, guys.